Let R be the shaded region bounded by the graph of y equals x e to the x and line y equals negative 2x. And the vertical line x equals 1 is shown in the figure above or off to the side here. A, find the area of R. Well, let's take the top curve, which this is x e to the x squared, and the bottom curve is negative 2x, and we're going from 0 to 1. So we're going to integrate from 0 to 1 of top, x e to the x squared, minus the bottom, so plus 2x dx. Now here, for this piece, we're going to let u equal x squared, so that du is 2x dx. 1/2 du is equal to x dx. So now this becomes, well, we're going to replace x dx with 1/2, and then we would have e to the u du. Well, the antiderivative of e to the u is e to the u, so we end up with 1/2, and I guess I could put that on the inside, 1/2 e to the u, or x squared, and then plus x squared, and we're going from 0 to 1. So 1/2 e plus 1, and then we'll minus. When we plug 0 in there, we're just going to get 1/2, and then plus 0. 1/2 e plus 1/2 is the answer to that one. Letter B, write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals negative 2. So y equals negative 2 is right there, because this has a slope of negative 2. So negative 2, or down 2, and over 1. Can I increase this just a little bit? How about 2 pixels? Not 3. 2. There we go. So we're going to rotate this. Let's get the half turn here, something like that. And there's the inside circle, and then we have the outside circle. So the outside radius is going from this curve down to negative 2. So we need pi, integral from 0 to 1, of x e to the x squared minus a negative 2, so plus 2 squared. There's the big radius, and we're going to minus the little radius, which is from the line down to that line. So negative 2x plus 2 squared dx. Letter C, write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. Let's switch colors here. So let's get this distance right here is the distance we get when we plug 1 into this. So we have E. This distance right here is 2 units down, so plus 2. And then this is the hypotenuse of a right triangle. There's the right triangle. So we have plus the square root of 1 squared plus 2 squared. And then we need this, the length of this curve right there. So to get the length of the curve, we need the derivative. That's first times the derivative of the second, plus the second times the derivative of the first. And if we factor an e to the x squared out, we get 2x squared plus 1. So then the length of the curve from 0 to 1, 0 to 1 is square root of 1 plus the derivative squared. So e to the x squared, 2x squared plus 1 squared dx. Let R be the, I guess I have it all written out. Let R be the region in the first quadrant bounded by the x-axis in the graphs of y equals natural log of x. So this is actually y equals natural log of x, and y equals 5x, 5 minus x. Y equals 5 minus x is that line over there. Well, we're going to need this intersection point. Let me get that. This point right here to 3 decimal places is 3.693, comma 1.306. Find the area of R. Well, we could split this up into the area under this curve to here, and then the area under the curve to here. But it's probably better just to go right minus left like this. So let's get x by itself. X is equal to 5 minus y, and here x is equal to e to the y, like that. So then if we go right minus left, that's 5 minus y minus e, and we're going from 0 up to this y right here, 1.306. So the answer ends up being 2.986. Region R is the base of a solid. All right, so base of a solid, and here's the natural log of x, and let's say that's the line. For the solid, each cross-section perpendicular to the x-axis is a square. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. So the cross-sections are squares, and the cross-sections, they follow the natural log of x, but then eventually those cross-sections are going to follow the line. So we're going to go from 0 to the x-coordinate, 0 to here, along natural log of x. So we have to square that because area, our cross-sectional area, is side squared. So the length of a side is going to the curve. But then eventually we start following the square, and the lengths of the sides is, the function value for the square, whatever x value we're at. The horizontal line y equals k divides R into two regions of equal area, right? But do not solve an equation involving one or more integrals whose solution gives a value of k. So I know we got a mess here. But what they're saying is we're going to find this line that cuts the area in half, somewhere here, k. So we're going to integrate from 0 to k, and we're going to go right minus left. So here's right minus left. And we know that the area is 2.986. We just need half of that. What is the slope of the line tangent to the curve when y equals 2? So should we get the point first? Let's go x squared minus 2 times 2, so that's 4x, minus 20 is equal to negative 15. So x squared minus 4x minus 5 is equal to 0. And we factor x plus 1. So x equals 5, x equals negative 1. So we really have 2 points. We have 5, 2, and we have negative 1, 2, like that. Well, let's get the derivative. So 2x minus first times the derivative of the second plus the second times the derivative of the first, and then minus 10. Oh, I wanted 10y first. I jumped the gun there. 10y dy dx is equal to 0. Let's factor out a dy dx, and we get negative 2x minus 10y, and get everything to the other side, are the other two things. So 2y minus 2x. So dy dx is equal to 2y minus 2x over negative 2x minus 10y. And we're evaluating this at 5, 2. All right, well, 4 minus 10, all right, 4. If I 4 minus 10 over, plug the 5 in, negative 10 minus 20. So I get negative 6 over negative 30. So I get 1/5. And then we're going to evaluate at negative 1, 2. So that's 4 plus 2 over. See, if I plug negative 1 in, that's going to be 2. Plug in 2, and we're going to get minus 20. So I get 6 over negative 18. I get negative 1/3. Here, let's let u equal 1/6 x squared plus 1. So du is 1/3 x dx. So we'll put in 1/3. Do we have 1/3? No, we don't have 1/3. We need 3. 3 du equals x dx. So we need 3 integral square root of u du. But now let's change these x values to u values. So if I plug square root of 18 in there, that's 18. 18 divided by 6 is 3. 3 plus 1 is 4. And if I plug 0 into that x right there, we get 1. So 1 to 4. Well, that's u to the 1/2. So we're going to add 1. That's u to the 3/2 times 2/3. So 3 times 2/3 u to the 3/2 from 1 to 4. So square root of 4 is 2. 2 to the 3rd is 8. So 16/3. And then minus when we plug 1 in there is 2/3. So 14/3 times 3 is 14. So here the first derivative is first times the derivative of the second plus the second times the derivative of the first. And we can take an e to the 3x out of this and get 3x squared plus 2x.